Okay, here's another one. This is after physical and chemical properties. I thought I'd take an opportunity to talk a little bit more about how we know if something reacted, because that is going to be important for our lab, our mystery powders. So this video is going to be super short. It was just purely demonstrations because there was a bit of an interruption and we didn't have much time. And I thought I would use the day to do a bunch of demonstrations to solidify our knowledge on this a little bit, and then talk a little bit about what you would do for the lab. So in other words, that's why we did a bit of a pre-lab and prep. Okay, I'll try to do that in this video as well. So as evidences of chemical change, there are four different ways we can tell a chemical change occurred. First thing is a color actually changes. So I'm not talking like, you have Kool-Aid and then you pour more water so it goes from red to lighter red. I'm not talking about shades here. I'm talking about actual colors. Like, you have a blue and then you mix it with the colorless liquid and suddenly becomes yellow. Okay. A gas is produced, in other words, bubbles. You see bubbles form, it's fizzes. Light is produced, or otherwise you can call it heat. Heat is produced from mixing two things together. Or for example, if I mix or if I create the reaction in a test tube, the test tube gets noticeably hotter, then we can say that energy was produced. Precipitate forms, and I'm not talking about rain here. I'm talking about you mix two things and something of a different of a solid state pops out. So one example I've done is there's some kind of liquid and I put in another solution. So some kind of solution is in a test tube. I put in another solution, okay, from another test tube. And when it mixes, it actually created this, I guess, a yellow film, and you see it start to sink because it's an actual solid and it's heavier than the water that it is in. Some examples. So this is a demonstration. I had some kind of acid and I placed a indicator, making it a darker red color. And then slowly I started putting in a base. And what I was hoping to see was a gradual transition from red to blue. So it goes from red to orange to yellow to green to, lighter and darker green into a bluish violet color. I didn't quite get that, but I mean, it is what it is. The observations before reaction, it was red. And then as I mixed these two colorless things together, it became blue. Next, I had a magnesium strip. So in other words, a piece of metal, purely magnesium, Mg, and I placed it inside a small test tube with a little bit of acid. The magnesium strip was sort of lustery silver, very malleable, very bendable. During the reaction, you saw it start to fizz. The areas where the solution came in contact with the metal started to fizz quite a bit and produce bubbles. And you can hear it. You can feel the heat as well, actually. And by the end of it, the metal was all quote unquote used up. There was a bunch of gas that was produced, and the remaining solution was just sitting there doing nothing. It wasn't this color, it was just doing that. Light. This one was a bit anticlimactic until I finally got it working. I had another piece of magnesium strip, and when I was able to heat it up with a torch, something really, really hot, this finally ignited, starting to react with the oxygen around in the air, and it gave off a super bright light, very similar to what I'm going to say like a military grade flashbang. It was very bright, very white and silvery, and if you look directly into it, your eyes were momentarily paralyzed and you would see spots if you blink, if you know what I'm talking about. Okay, and that was during the reaction. And after the reaction, the metal strip simply turned into a white ashy compound that was just sitting there on the table. Okay, it was just white ash. Precipitate form. So I didn't have calcium chloride and sodium carbonate. So instead I used potassium iodide with lead nitrate. And what that did was, as I said, it created this, when I mix it together, I fix the concentration so that it would immediately create this yellow film, like it made the colorless liquid thick yellow. And some people might confuse that as a color change because, oh, clear became yellow. But the yellow isn't because the solution itself turned change in color. We actually produced a yellow solid, a yellow flakes. And soon enough, you see these yellow flakes start to sink as if it was a snow globe. It actually starts to sink to the bottom. Okay. Those are the 4 different types of color change. So if you see anything like this in the future, whenever you do a chemical reaction or chemistry lab, you can be sure that something new was created and something old was used up and something new was created. Okay. That's essentially the summary of this section. So going back to that part where gas is produced, the gas production part is actually sort of interesting because just because we know a gas is produced doesn't really help us. Knowing what type of gas can actually help or even harm us depending on how much we know about it. So there's another demo that we did that actually tests what type of gas was produced. Specifically in the grade 9 level, we can quickly and easily test if the gas's identity is hydrogen, oxygen, or carbon dioxide. The first test that we can do is called a glowing splint test. And this glowing splint test confirms whether something is a oxygen or not. What you do is you take a splint, or take like a little piece of wood, you light it on fire, and when you extinguish the fire, there is this glow, sort of like coal of a barbecue or of a campfire, if you know what I'm talking about. It's just glowing red. If you put it inside a test tube of oxygen, the oxygen will feed the glowing embers enough that it actually reignites back into a fire. This is what I did. I took some hydrogen peroxide that you can find at Shoppers Drug Mart, so 3%. And from here, I threw in some potassium iodide, which is a catalyst that allows the oxygen that's trapped inside here to run out. It just releases. And so I have this bit of potassium iodide. I throw in the peroxide. I throw in the potassium iodide in there, and all this bubble starts to be released. I trapped it all with a rubber stopper, and then when I was ready, I threw in a kindle, sorry, a smoldering splint, and it was able to reignite. So we know that it's going to be oxygen. Another test that we can do to confirm the gas is a burning splint test. So this actually confirms whether something is hydrogen gas or carbon dioxide, depending on. So here was my hydrogen gas. I took the exact same thing as I did with the gas production earlier. I put in magnesium inside acid solution. And as the bubbles were produced, I actually took a larger test tube and trapped all the gas inside here. Once I was ready, I took this, I placed a burning splint inside it and actually created a big pop sound. In other words, I combusted the hydrogen gas. I blew it up. Okay. And of course, it's not violent. It just makes a small pop. But you see that there was an explosion. It was a very clear explosion, confirming that it's hydrogen gas. I could do the exact same burning splint test, but with carbon dioxide. And if I have a beaker or a test tube full of carbon dioxide and I put a burning splint into it, it will snuff the fire, leaving nothing but smoke. And you can confirm that anything that can actually kill fire that quickly is carbon dioxide gas. Now, this is sort of a pseudo test. A true test to confirm carbon dioxide is by actually putting carbon dioxide into lime water. In other words, calcium hydroxide. If you bubble in carbon dioxide into it, the calcium hydroxide will start to react with it, turning this into a cloudy, milky substance. What you're doing is actually creating a precipitate, but that's not important right now. That's much later. You actually make it cloudy. If the calcium hydroxide solution becomes super cloudy, we know that the air or the gas blown in is carbon dioxide. So the three gas tests. It's something that you ought to know. It's a lot easier to know if you've seen it, but try to recap it. Okay. Oxygen is when you throw in a kindled splint and it reignites. Hydrogen, you put a burning splint, it pops. Carbon dioxide, you put it in and it snuffs out. Hope this is helpful. We'll see you in the next video. Oh, I lied. I totally forgot about actually going into the mystery powders. The mystery powders was the lab that we decided to do the next day. I'll give you the instructions on what happened, and then you can collect the data either from your friends or if you have the opportunity. I like to actually get you to perform it yourself. And then the rest of these questions can be done after you have data on it. Okay. I also see that an answer key is, anyways, it is what it is. Yeah, I'll give you quick rundown of what the mystery powder is when I see you. Yeah, stay tuned for the next video.